Welcome to Delft. Delft is known for its Delft blue porcelain, its ties to the royal family, and Johannes Vermeer. What many don't know is that within the Netherlands, Delft is actually known as the city of knowledge. Since the establishment of the University of Technology, Delft has been known to reproduce countless talented engineers specialized in many different fields. Delft University of Technology is located just outside of the historical center of Delft. The university is attended by approximately 19,000 students across 15 faculties. Although the university is known for its technical expertise, the faculty buildings are not always up to par with current standards. One of these buildings is the Faculty of Architecture. Since the burning of the former Faculty of Architecture in 2008, the faculty has moved into the old headquarters for the Technical University's administration office. Large amounts of students were introduced into the building, which was planned on being renovated and fit for apartments. Today, the building is used by large amounts of students, pushing the boundaries of the building in many ways. Not only is there insufficient space for the amount of students, but the technical installations are insufficient, causing a lot of discomfort throughout the faculty building. Our task is to redesign the Faculty of Architecture whilst increasing user comfort and reducing the carbon footprint without compromising on its monumental facade. This is the section of the most southern wing of the faculty. To improve the section of this wing, we should first identify the problems of the faculty's current state. The first and most apparent problem is the lack of insulation throughout the building, resulting in large amounts of heat loss. The solution to this problem is rather simple. Redesigning the facade and roof with a layer of insulation will drastically lower the amount of heat loss. The second problem is the way these spaces are heated. In the current situation, there are radiators on the walls, radiating heat into the air. Since air is not such a good heat conductor, it's much more efficient to use floor heating. The impact of the ceiling height on the indoor climate is also of importance. The ceiling height creates a noticeable difference in room temperature across different heights. To solve this problem, high-volume, low-speed fans can be installed to de-stratify the air, so that there is one temperature throughout the entire space. This also means that there is less heat needed to reach the wanted room temperature. The biggest problems in this section can be identified when we look at the design studios on the second floor. This is by far the most problematic space in this section. Many of the comfort-related problems are due to the large amount of people. Especially the heat that the students and their equipment produce is problematic. The design studios are overcrowded, resulting in a hot and insufficiently ventilated space. The fact that windows cannot be fully opened to create a draft or allow more fresh air to come in doesn't help. So how can we redesign the Faculty of Architecture whilst increasing user comfort and reducing the carbon footprint without compromising on the facade? Our design is based on a simple principle: to divide spaces for different demands and activities. The box is key in our design. It contains the studio spaces, now divided over 2 floors, and separates these from the walking spaces. The use of the full height of the room and the division of different demands opens up more options for climate control, natural light, and an increase in comfort. The studio spaces inside the boxes are climatized, whereas the walking spaces, due to their lesser demands, function as a buffer zone. The energy needed for our climate control comes from the ground. A closed-loop geothermal energy system is used to keep these boxes at a stable and comfortable temperature. This is the concept on which we can elaborate in our individual design.